It's sort of the million-dollar question, I guess, of why we haven't been more successful with all of the energy that's been spent in pursuing our understanding of how cancers arise and progress. I think it's just a challenge. Cancer is not an engineering problem. Cancer is really a human problem, and cancers are very different from one another. As much as they're alike, they're different from one another, and even within a cancer, they're cell-to-cell variations. So this fact that it isn't a set distance that we need to travel, like flying from Earth to the moon, or there's not a certain other engineering or knowable aspect to all of it, is really, I think, one of the challenges about cancer. At the end of the day, it's a human problem with lots and lots of barriers that we've overcome, but still more that we have to traverse. I think the risk is not necessarily always an obvious one. So part of the risk is that we won't be able to pursue some of the really important work to improve health and cancer patients in particular, their health and outcomes. But we also face, I think, some likely impact on the career paths that the most promising young individuals in our society might pursue. So if they see that there's not support for biological research and its application to improve human health, they might choose other career paths. And so I think it's potential that we could have a lost generation or even two lost generations who don't pursue careers in biological science and in biomedical science because they feel that these aren't careers that are going to be possible in the future. So I think it's really important to inspire the young people, the young scientists, the young people interested in careers in science, technology, engineering, and math, and in biomedical research to pursue that. And so I think as long as we can inspire that next generation, I think there's great hope that we can have a major impact on cancer patients and their quality of life and outcomes. So we're really appreciative of all of the federal funding we're able to attract, but the really tight federal funding and the challenging funding environment is both I think a near-term challenge and also an opportunity for us. The pay lines for federal grants for the National Cancer Institute are perhaps around the 8th percentile, which means that only the top 8 out of 100 grants are able to obtain funding. So philanthropy and the opportunity to launch new ideas and high-risk, high-reward research for our faculty and trainees is really critical to our ability to compete effectively at the national level. So the better we can cement the feasibility of the research we're proposing and generate encouraging preliminary data to support the likelihood of success, the higher the likelihood our researchers will have in succeeding when they put these grants out to the National Cancer Institute or to other institutes within the National Institutes of Health. For everybody, it's really a lot of work. You could talk to almost anybody here at the University of Michigan who's had grants submitted and not supported or didn't score very well when they were submitted, and it can be very discouraging to receive negative comments and critical remarks. Sometimes they're very helpful, they're constructive comments, and those can still be painful, and then sometimes the review comments seem a bit off the mark or perhaps a little esoteric. It's a very unfortunate position to find oneself sort of sitting at the 11th or the 12th or the 15th percentile. One can sometimes lose hope that your grant scored really well. There were perhaps even no flaws found in the grant at all. It just wasn't received positively enough by the reviewers and the review committee that it got a score at the very, very top level. Well, grant review bodies often bet on the tried and true, the investigators who have really stellar track records and the ideas that seem to be the currency of the time. Those new ideas sometimes don't gain traction at a grant body until maybe a number of people think they're important. There are obviously good reasons to study some of the same genes and signaling pathways that we know are at the heart of cancers. But we can also be a little too conservative in what we do if we just study those. They've been challenging to come up with new therapies based on those, their sort of lack of drug abilities. So I think there's this balance between studying the sure things, the sort of portfolio of sure things versus the risky things. And obviously we want a balanced portfolio, just like we would for finances, to have a sort of some sure bets, that studying those things in new ways and applying new technologies to study the sure things is a good way to go. But there's also this importance of studying some of the unknowns because of their potential. So the Rogel gift is a really unique one. It's got 6 distinctive features that are really unique to the University of Michigan, and it allows us to impact on research across the cancer research continuum and across the career pathway of our faculty as well as our trainees. We really need to continue to make discoveries about what fuels and sustains cancer from its origins to progression, and as well as how to take advantage of those pathways it's put on in the stuck-on fashion, or removing the brakes, and as a result has vulnerabilities. So besides sort of targeting cancer itself, we could always do more in preventing it and in early detection of it. Most importantly, we think through the discoveries we'll make, through the innovation and applications that will be developed here at the University of Michigan, training the next generation of cancer researchers, we think we'll have dramatic impact on the cancer patients we see here at the University of Michigan, cancer patients in Michigan and in the Midwest, and nationally and beyond, through the discoveries and applications and bringing new approaches to improve cancer care, cancer prevention, and quality of life.